Hello friends, my name is Mohammad Hanif, Assistant Professor and Head Department of Environmental Science, Kohinoor Arts, Commerce and Science College, Kultabad, District Aurangabad, Maharashtra. Today we are going to see about fundamentals of remote sensing. Here we are going to see about what is meant by remote sensing, its type, principles of remote sensing, its stages, EMR and EMS, interaction of EMR with our surface, with atmosphere and satellite orbits. So, what is meant by remote sensing? It is the act of acquiring information about the Earth's surface without being in actual contact with it. Remote sensing can be achieved by using spaceborne sensors or airborne sensors. Spaceborne sensors are satellites, while airborne sensors are aeroplanes. Remote sensing techniques allow us to take images of Earth's surface in various wavelengths of the electromagnetic spectrum. It could be the visible region, it could be the near infrared or thermal infrared region. There are two types of remote sensing basically based on the energy source used. One is active remote sensing where the platform uses the source of energy, uh, its own source of energy. The widely used active remote sensing systems are radar, lidar, and sonar. When we use sun as a source of energy, then it is called as passive remote sensing. The passive remote sensors are Landsat TM, AVHRR, Spots, Modis, Iconos, QuickBird. These are few examples. The resolution of the sensor may be coarser or higher. Coarser resolution means less resolution. Here are some example. Landsat thematic mapper. It is a example of coarser or less special resolution sensor. It is generally 30 meter in resolution in color image and 15 meter in panchromatic image. Most common use of the Landsat TM is land cover mapping. MODIS is the another example of coarser resolution. It generally uses 36 spectral bands, and uh, commonly used to study cloud and aerosol properties, ocean color, atmospheric water vapor, and atmospheric temperature. These are the example of high resolution sensors. Iconos and QuickBird. Iconos having 4 meter of visible and infrared resolution and 1 meter of panchromatic resolution, whereas the QuickBird is having 2.5 meter of multispectral resolution and 61 centimeter, that is approximately 2 feet of panchromatic resolution. Most common uses for high resolutions are accurate base maps, infrastructure mapping, disaster assessment. Principle of remote sensing. Detection and discrimination of objects of surface features are means detecting and recording the radiated energy reflected or emitted by the objects or surface material. Different objects return different amount of energy in different bands of electromagnetic spectrum incident upon it. This depends on the structural, chemical, and physical properties of the material, surface roughness, angle of incidence, intensity, and wavelength of radiant energy. A remote sensing system is generally a multidisciplinary science. It includes it includes spectroscopy, optics, photography, computer science, electronics and telecommunications, satellite launching, etc. What are the stages involved in remote sensing? So, emission of electromagnetic radiation. First stage, transmission of energy from source to the surface of the earth, as well as absorption and scattering between interaction of EMR with, that means interaction of EMR with atmosphere. Then interaction of EMR with Earth surface, reflection and emission. Once the energy reaches Earth surface, reach the Earth surface, it gets reflected back and emitted back. This transmission of energy from surface to the remote sensor. Then after reflecting back from the Earth surface, it again passes to the atmosphere and reaches the sensor. The sensor records the data, it gives the output, and that data then transmitted to the lab, and then it is processed and analyzed. What is EMR? EMR is electromagnetic radiation. It has two components, electric field and magnetic field, and both are perpendicular to the direction of propagation. This is the structure of electromagnetic spectrum. It ranges from gamma rays to the radio wave. Once you move from left hand side to the right hand side, from gamma rays to radio waves, the wavelength increases, energy decreases, and frequency also uh, decreases. And there is a small portion called as visible light. It is a small part of a spectrum, and that is the only portion which is visible by the naked eyes. It ranges from 400 nanometer to 700 nanometer, and once we pass this visible light through the prism, it will give from violet to the red colors. The interaction of EMR with Earth surface. Once the incident energy reaches the Earth, it get the part of it get reflected, part of it get transmitted, and part of it get absorbed. So the total incident energy is equal to the addition of all three parts. Interaction of EMR with atmosphere. The information carried by EMR reflected or emitted by the Earth's surface is modified while transmitting through the atmosphere, and sometimes the interaction of EMR with atmosphere can be used to obtain the useful information about the atmosphere itself. This is the diagrammatic representation how the radiation interact with Earth's surface and atmosphere. So the scattering is one type of interaction of radiation with the atmosphere. When the particle size is less than the wavelength of the radiation, then it is called as relay scattering. When the size of particle and the wavelength are equal, then it is called as Mie scattering. And when the particle size is greater than the wavelength, then it is called as non-selective scattering. These three types of scattering occur in the atmosphere, and the part of the energy get absorbed by the atmosphere. The absorption is one phenomena, and of course the refraction is another one. So this kind of interaction occur when EMR passes through the atmosphere. Next is satellite orbits. There are two types of satellite orbits: geostationary orbit and polar orbit. The geostationary orbit, the satellites, weather satellites, meteorological satellites placed in the orbit of geostationary are placed in a geostationary orbit. It focuses on the same area of the Earth all the time, and that's why all meteorological information can be obtained. And it revolves with the speed of the rotation of Earth, and it revolves around the equatorial plane. In polar orbiting satellite, the orbit moves from pole to pole, and Earth rotates perpendicular to the direction of the orbit of satellite. So the in every pass, satellite records the different geographical area, information of different geographical area. Yes, this is my references. Thank you.